conducted by AstroSTEM Labs in association with ORMA, which is the Ontario Regional Malayali Association. This session will also be recorded, okay? And let me introduce Ms. Jaya Nair. She is currently an independent consultant, and she was the former head of division for the Vikram Sarabhai Space Center for the ISRO, which is the Indian Space Research Organization. She spent nearly 3 decades working in the ISRO in technical and techno-managerial areas. She will be talking to us about the topic of nature as the teacher today. And before we start, I would like to say, if you have any questions, please type them in the chat. And at the end, we'll have a Q&A section, and we will try to answer as many of them as possible. And without further ado, I will pass over the virtual mic to Ms. Jaya Nair.
Hi, thank you very much, Safal, for that introduction. And thank you, AstroSTEM Labs, for inviting me and giving me this opportunity to talk to all of these smart friends. Very happy to be here. So shall I start? We can start now, isn't it? I'll just share my screen. Just one moment. Is that coming okay?
Yeah, it's good.
Right. So I'll just put off my video for the time being because, and then again switch it on. Just a moment. Just some problem with sharing. I'll just share it once again. Is my screen coming okay now?
Yep, you're good to go.
Okay, then we'll start. So friends, you must be having teachers in many areas, isn't it? You have teachers in your school, in the different classes that you will be going to, and also in these kind of online webinars. There also you have teachers telling you things and teaching you things. But today we'll be talking about another teacher, one who is always around you, the nature. Okay. So essentially we are talking about our Earth. You know, this is the Earth, isn't it? Our planet. This is a photograph of the Earth which has been taken from outside the Earth, from the outer space, from one of the satellites that are orbiting the Earth, the satellites which we have put there, humans have put there. So this is the photograph of the Earth, and Earth as it looks today. You know, this is how the Earth is organized, isn't it? The different continents, the different countries, the oceans, and so on. This is how Earth looks today. But you know, Earth was not like this all the time. There was a time many years ago when the Earth didn't even exist. And in fact, the whole universe itself didn't exist. It was about 13.7 billion years ago that the universe was formed from a very dense, tiny, small particle by an expansion which cosmologists and scientists today call as the Big Bang, the event, the Big Bang. Then the universe evolved. So what is this 13.7 billion years ago? 1 billion is in fact 1 followed by 9 zeros. If you put 1 and then 9 zeros, that's a huge number, isn't it? So 1 billion is so much years. And like that, 13.7 billion years ago, the evolution of the universe started. Then over many years, many billions of years, slowly the different things evolved. Like the stars came, and then the galaxies, Then our own star, the sun, existing, and then the different planets, the solar system, and our Earth itself was formed. So Earth was formed around 4.6 billion years ago. So, but that Earth which was formed at that time did not look like the Earth that we see us today. It did not have any life. There was no life, no animals, no human beings, no plants, no oceans, no water, nothing. All these evolved slowly over again billions and billions of years afterwards. Then slowly small life forms started, small bacteria kind of life forms, and then bigger forms. Then slowly plants came into existence, then different kinds of animals, and finally the modern human beings or the Homo sapiens came into existence. That was about some 300,000 years ago. So just imagine how the earth or the world would have looked to the first human beings. They did not have any clothes. They did not have any buildings like we have. They did not have any of the facilities which we have today. They did not have fire. They did not know how to cook food. They did not have any tools in their hands, isn't it? All of these things were made slowly by human beings over the 3 lakh years that followed. So for that, how did they do that? They did it by looking around, isn't it? Taking cues and taking lessons from the teacher which we are talking about, the teacher that is around us, the nature. So think about the different problems that they had to solve. The first human beings have to solve. One of the problems was that they didn't have anything by which they could bear the cold, isn't it? They had nothing to put on for the cold. So what did they do? They must have looked around and seen that many of the animals have the kind of skin and fur which actually protected them from the cold. So then our first ancestors, the great ancestors, must have taken the skin of these animals. How? The skin of the dead animals. Perhaps after eating their flesh, they would have taken the skin of the dead animals and then covered themselves with that fur, that skin and the animal fur. And then they found that, it is actually better. They're able to withstand the cold in a much better way, isn't it? So then it was from the animals, the first ancestors who took those animal hides and then used them to solve their issue, to solve their problem and make their life better. So that was one case of a lesson being taken from the nature, isn't it? So this has continued all around us, all through the years. Birds have always fascinated human beings because human beings cannot fly, isn't it? We cannot fly. Whereas when we look at the birds, we see that the birds can fly. So always through the years, human beings have looked at the birds and tried to find out how they are flying. What is the way they are flying? How are they using their wings and so on? And so that they are trying to find out the way by which they can construct a machine which will help them also to fly. So I'm sure, friends, that all of you must have heard of Leonardo da Vinci, the great Italian painter, sculptor, who was actually what is called a polymath. He was well-versed and an expert in many different fields. So Leonardo da Vinci also studied birds, and he actually made more than 500 sketches of the type of a machine which can actually be used as a flying machine. This is one such sketch that Da Vinci made. This is called a sketch of an ornithopter, which is actually a flying machine which tries to emulate the wings of the birds. How the birds flap their wings and they're able to fly. This particular sketch was never made into a machine as such. It was 500 years ago that Da Vinci lived. So that time, the sort of science and other mathematics and other capabilities were not there by which he could actually make this into an actual machine. But he made the sketch. And many years later also, over the 100 years that followed, over the 500 years that followed also, birds continued to inspire people to make the designs for a flying machine. And you have seen birds who glide, isn't it? Who, without using their wings, they're able to keep themselves afloat in the sky for a long periods of time. They slowly glide. birds like albatross or falcon and so on. So the gliding action of the birds also scientists have studied, tried to study and then tried to make gliders. This particular glider was actually made over, I would say, nearly 200 years ago in 1860s, when the construction or the development of a flying machine or an aeroplane, many people were trying to develop that, and this is one of the gliders which were used. Now, the difference is that the glider doesn't have an engine as such. It tries to position itself and use the lift of the air in order to keep afloat. And then slowly it will be slowed down, and then it will land. And you know that after all these trials, which went on for many, many years, it was the Wright brothers, isn't it? In 1903, that they were the first people who could actually construct a heavier than air machine like this and then keep it afloat for a period of time. It was a powered flight. So such a flight was first time done in 1903, the year 1903, by the Wright brothers. And they also, in this construction also, many of the principles by which birds fly were actually used. And you know that the evolution of the aeroplanes continued afterwards, and this is how our present aeroplanes look like, isn't it? But even in the construction of our present planes, many of the basic principles which are actually used in the bird's flight are still being adopted. So this particular mechanism by which we look at the nature and try to see some of the function or a structure or a material or a process that is working in nature and try to get an idea from that and adapt it to solve our own problem. This particular process has got a name. It is called biomimicry or biomimetics or bionics and so on. So what does it mean? Bio means life. Okay, it's a Greek word, it means life, so that means nature. And mimicry means to imitate. So we are trying to imitate or we are trying to adapt things from nature. So this is a field which is now growing very fast. Many people are engaged in doing things like this, in which they are trying to find solutions from nature. Now, you remember that in nature, everything evolved over billions and billions of years, isn't it? So whatever we see in nature are the result of experiments conducted over billions of years. So we are surrounded by such perfect solutions for certain problems. So we are trying to take and adapt those solutions to suit our problems. So there are many, many examples. Many products have been made by many people. We will just go through a few examples. There are many, many more, but we'll just see a few more examples of such biomimicry in practice. Right? So look at this. You must have also gone and sit in grass or lawn for some time, and afterwards when you get up and leave, you find that some of these grass particles are sticking to your dress or your socks, your gloves, etc., isn't it? We see that. This particular story was happening in 1841, many years ago, nearly 200 years ago, 1841. In Switzerland, an engineer, he was trying to, he along with his dog, they went for shooting in the Alps mountains. They spent the day there and then came back home. And then he found that not only in his dress, but on the body of his dog also, the burrs of this particular plant, the small particles or small grass particles of this particular plant, which is called burdock burrs were actually sticking to them. That he was actually, it is the method for this plant to actually spread its seeds over far areas. The plant always wants to spread the seeds to far off places, isn't it? So it is the mechanism used by the plant so that the people will carry the seed along with the burrs and then it will be taken to far off places. So the Swiss engineer de Mestral, his name was de Mestral, he actually put this burdock first on under the microscope. He examined it. How was it possible that the burrs were sticking to his clothes? He put them under the microscope and found that these tiny particles have very small hooks at the end. You can see those hooks there. The tiny particles had the hooks, And these hooks were actually getting aligned to the loops which are there in our dress. Our dress always has loops in them, very small, tiny. And also the dog's hairs, dog's fur also had loops in them. So the burrs were, these tiny hooks of the burrs were getting entangled into the hooks, and that's how it was getting stuck to the dress. Then this gave an idea to demonstrate about why not make a material like this, which will be able to be used as an adhesive, as something to stick things together. And he spent many, many years of experimentation with many types of materials, and finally what he found out is velcro, which I am sure all of you know about, isn't it? The velcro, the adhesive that we use, right? In which there are two parts. It has got two parts, two nylon strips. One strip has got a number of small hooks in them. You can examine your velcro shoes next time. Small hooks, and the other side has got tiny loops. So when you press together, the hooks get entangled into the loops and the two parts stick together. Just by exerting a little pressure, you can disengage them and then the two parts again come apart. So this Velcro has got an enormous number of applications in shoes, in bags, in clothes, and so on. Many, many types of applications. This is one this is one example of directly taking an idea from the nature and then adapting it and using it to prepare a very useful product which we can apply in many, many applications. Right? So that is the Velcro story. Now we'll go forward. Now you have seen these lizards, isn't it? The lizards are able to climb the walls. We have all seen that. They're able to go up the walls, the vertical walls. They're able to climb, which we are not able to do. And they sometimes even run through the ceiling, isn't it? Upside down. They will be wholly upside down. So this movement of the lizards, there is a kind of lizards called the gecko lizards, which are very fast. They are able to move very fast through these vertical surfaces. So some scientists wanted to study how they are able to do this. So they studied the limbs or the toes, the skin of the gecko lizards, and they found out that it was because of very tiny hairs which are at the bottom of their toes. Very tiny hairs at the bottom of the toes of the lizards. So when the lizard was pressing the toe onto the wall or onto the surface, then it gets pressed and then it gets stuck onto the wall. So this was what was happening. These are very, very tiny particles. So when the very tiny particles, and there are huge numbers of them. So when the whole numbers are pressed onto the wall, the essential, the force that gets pressed becomes the surface area that gets pressed becomes huge because of the huge number that is involved. And then the lizard was able to stick to the wall. So then many scientists try to develop a material like this. If we have a material like this, which when we can press onto the wall, it gets stuck without using any gum or any other adhesive, and also by exerting pressure, if we can easily release it, then that will be of great use, isn't it? In fact, material like that has been prepared. It's in the laboratory. It has been prepared, and there are many applications which have been it is being used. For example, it is being used for robots. Some robots, if their hands are having these kind of materials, then they'll be able to clutch on to a certain surface and then even pull very huge weights. And there are some applications for which these kind of materials have been used in the space-based repairs, maintenance works, and so on. But it is hoped that this kind of a material in larger quantity can be made. Just think, what does it mean if such a material in large quantities can be made, and then if you are able to get a gloves and socks, or a dress which is of this particular material, then it may just be possible for you also to climb up the walls and the ceilings like this person here, isn't it? Like a Spider-Man. That may be a reality one day. How do we know? We just have to wait. Let us go to another example. You know the whales, isn't it? Whales are huge animals, huge mammals, which are in the with water animals. They live in water in the oceans. They're very huge. The whales have inspired many, many applications, many innovations. And one of them is the design of the submarines. Submarines are the vessels which run underwater. The design of the submarine, just see, the design of the submarine has been inspired from the shape of the whales, so that it actually helps to efficiently go underwater, to reduce the drag and to go underwater in a more efficient manner. And the whales also use a method called sonar, that is use of sound waves in order to find out whether there is anything near it, any obstruction near it. So the same kind of sound waves has been employed in the submarines as well. But there are other things also which whales have inspired. You know about the humpbacked whale, a whale which is huge, I mean, nearly 40 tons. That's the weight of such humpbacked whales. But even when these kind of whales are so huge, they are able to jump over and swim and go through the seas in a very fast manner. They're very agile. So many scientists studied how it is possible that these whales are able to be so agile even though the body weight is so huge. Then what did they find? They found that there are tiny protrusions or tiny bumps, like what is shown here, all over the front side of their fins. Very tiny bumps like this, tiny protrusions. And it is these protrusions which are actually making the water to go into holes or vortices in the ocean. And that was actually helping the whale to move so fast. And these scientists try to apply this kind of bumps on the blades of turbines. You know about turbines, which are huge fan-like structures which rotate at a huge speed and try to build electricity from wind energy and so on. So these turbines, when such bumps were, small protrusions were applied to the fans of the turbine blades, then they found that the amount of noise that the fans were making were very much reduced. They became more efficient. And the same technology is today being applied to pumps, to other ordinary fans, and so on. So those are innovations in which the whales have actually helped us. Let's go to another example. You know about the Japanese bullet trains, very fast trains which go at the speeds of about 300 kilometers per hour and so on. They're very fast trains, but there was one problem. When these trains typically come out of tunnels at such a huge speed, there used to be a very big sound, noise that was being made. Which is because of the difference in air pressure between inside the tunnel and outside, huge noise used to happen, and it used to disturb the people who are living nearby. And many engineers tried many mechanisms to somehow solve this issue. And then they noticed the kingfisher bird. You know this kingfisher bird, isn't it? A sleek bird which flies at high velocity and is able to go into the water without making even a splash. It will just like that seamlessly get into the water. So then they studied the beak of the kingfisher bird and then redesigned the front portion of the bullet train like this. The front portion of the bullet train was redesigned to look like the kingfisher's beak. Then what happened? That noise problem got very much reduced. Not only that, the trains were able to run with even less power, less electricity, and they even became even more fast. So that was the kingfisher bird which actually helped the bullet trains, the Shinkansen bullet trains of the Japan. Let's go to another tiny creatures which have inspired us. I hope you know about termites. Termites are very tiny insects which are there in places like deserts and so on. And some of the African termites build huge mounds. The mounds are made of clay along with certain secretions that the termites themselves which come out of their own body. So these huge termite mounds are sometimes 2 meters tall. But even then, people notice one thing, that even when the outside temperature goes between 40 degrees Celsius to 1.5 degrees Celsius from daytime to nighttime, that's about 104 Fahrenheit to around 35 Fahrenheit of temperature change, The termite mound inside is always kept at a very uh, good temperature. I mean, it doesn't go through these variations. So how are the termites doing that? It turns out that the termite is mound is very much porous. It has got large number of vents are there, holes are there all through the sides and also at the top. So there is a very good air circulation that is going on, and that's actually contributing to this maintenance of temperature. Then some engineers and architects tried to build the same kind of technology into a building. And this building is known as the East Gate building, which is at Zimbabwe in Africa. And this particular building, you can see that it's a multi-story building, which is both a shopping complex and an office building. And in spite of being such a huge building, there is no conventional cooling mechanisms are employed in this particular building. It is built taking cues from the technology that is used by the termites. It has got a number of air vents are there, and the building is constructed using a material in such a way that during the daytime the temperature will be absorbed by the building materials, and in the night time the cool air will be sucked in through the bottom and it will be circulated so that hot air goes out of the building and the building gets ready for the next day. And they found that the building has been able to operate without any of the conventional air coolers or air conditioners for so many years, and then the amount of power that the building consumes has also been reduced. So that is a lesson that has been learned from the termite mounds. Let's go to another example. You know about the huge buildings, the multi-story buildings which have got glass windows, isn't it? Or even one full wall will be full of glass. Now, one problem for these glass faced buildings, the problem is that the birds are not able to see the transparent glass. So what will happen? The birds will fly into the glass and get killed. We even though we cannot see the glass, we can make out the glass. We learn about the glass, but that the birds are not able to do that. And actually the huge numbers of birds like hundred thousands of birds used to be killed every day by flying into these huge glass buildings. Then how to solve this problem? Then the scientists found that the birds usually avoid spider nets. You know, the spiders build their spider nets everywhere, isn't it? Even at the top of big buildings. But birds do not usually go inside the spider nets. Why is that so? That they found that the spider nets have got a small coating of a material which reflects ultraviolet light. You know about ultraviolet light, which is one kind of light in the entire spectrum, which human beings, we cannot see the ultraviolet lights, but birds can see them. So the spider nets have got the coating that reflects ultraviolet light, which birds see, and hence the birds are able to avoid spider nets. So then the scientists tried to build this technology into the glass. And a certain kind of glass, which is bird friendly, has been made, in which small coating of such a material in a particular design will be made inside the glass in such a way that it will reflect ultraviolet rays. So we won't be able to see that. We won't be able to make out that, whereas the birds will see the glass like a spider net or some pattern they will see. So they will know that it's not a free space to move inside. They will avoid that. And in fact, huge numbers of bird deaths have been avoided by the use of these kind of bird-friendly glasses, which have been inspired by our spiders. Shall we move to the next example? One more example, and this is the lotus leaf. I'm sure you know about the special quality or the special property of the lotus leaf. Water cannot uh, actually wet the leaf, isn't it? Water particles will not be able to stay on the leaf. The leaf repels water, so water becomes small bubbles and it just drops off, spills off the leaf. And this is a good cleaning mechanism as well. If any dust particles or dirt is there on the leaf, the dirt also will get washed off along with the water. So that many people studied this. Why is it possible? How is this being done? They found out that it is because of very tiny micro protrusions on the surface of the leaf, which are coated by a material which repels water. Those kind of materials are called hydrophobic. And this property itself is called superhydrophobicity. So then scientists try to build a material which has the same property, or a coating which has got the same property, and such coatings have been made. Coatings which can repel water or repel oil or repel fat and so on. And if you have a fabric which is made of that sort of a coating, then that also will repel water. And this has been made, and it has been made into many kinds of applications like shoes or tablecloths or surgical instruments, or even this has been used to apply to the surface of ships, so that it can prevent corrosion actually, because the water just keeps dripping off. So that is the lesson from the lotus leaves. So next who is going to teach us? The bees. I'm sure you have seen beehives. A typical beehive will have thousands and thousands of bees in them. But if you look very closely, and people looked very closely, and they found that even though the bees are spread all over the beehive, they're always busy, they're always doing something. All the bees are doing work, the combined work of the beehive. But at the same time, there is no central control. It's not like one person directing all the bees, it's not there. What happens is that the bees are just looking at each other. They're looking at the bees who are nearby, and then depending on where they are and what is the kind of work that is to be done, they just do the work. So it is sort of a distributed control. There is no central control. So this particular idea, which is called a swarm logic, this has been applied in many processes in our daily life. And one of the processes is guess the transmission of power, the electric grids, which carry electricity from the station from where it's being generated to far off places, isn't it? All over the country. So in these electric grids also, instead of having a central control, local controllers are deployed at all over the grid, who actually communicate together with the local controllers nearby and then adjust the power levels accordingly. I mean, as needed. They take the decisions locally. So the bees swarm logic has been applied into such applications. They have also been applied into making groups of robots which work together. Again, by this kind of a sharing mechanism. So there are other lessons which have also been learned from bees. If you put the beehive under a microscope, you will see a structure like this. It consists of a number of tiny six-sided figures. Six-sided figures are called hexagons. These are tiny cells, hexagonal cells, into which the bee will be storing the honey, their larvae, and so on. And these hexagonal cells are made by the bee using a wax which it secretes. Scientists have found that this is one structure which, even though it uses only very little material to make it, but it's very strong. The beehive has to be very strong to last in spite of all the variations in climate and so on. At the same time, it cannot the wax that is needed to build it, the bee can secrete wax only by consuming lots of honey. So only little material can be used. So this particular structure, which is called honeycomb, has been adopted, and then people try to make a synthetic material which has got the same structure. That is the honeycomb structure, which has been made in aluminum, in different kinds of composites, as well as in fiberglass and so on. And this has now got applications in many, many areas, from making furniture to making aeroplanes and in making rocket parts. The main advantage is that it's very lightweight, at the same time very strong. So honeycomb structures, which are used in even aeroplanes and rockets, are the lesson that we got is, or the idea that we got is from the beehive. Do you know what is this? This is a wood wasp, a kind of wasp which lives in the wood, and then it has got a long needle-like structure which the female wasp will pierce into the wood before laying eggs. Now this particular aspect, that a long, very flexible needle which will pierce the wood and then allow the wasp to lay eggs, was studied by many people who wanted to build a needle, a surgical needle, a syringe, which can then be used to do operations on very finite control, like the brain surgery kind of operation. So that the such a needle, which will be computer controlled, has been made so that it is able to slowly go inside, go around tissues, so that only the particular body part of the tissue which has to be operated can be need to be affected without affecting any of the healthy tissues that is surrounding it. So a computer controlled such a surgical needle, which is inspired from the wood wasp, has been made, and it's being refined. Another example, you know about the viruses. We are actually in the middle of the attack of a virus, isn't it? All over the world now. Now, you know that in certain treatments, like the treatment for cancer, the doctors have always been trying to find a kind of drug delivery mechanism which will go directly into the particular body cell which has got the disease, and then deliver the drug only to that particular body cell without affecting any of the other healthy tissues. Now, the inspiration is a virus. You know how the virus works? The virus does not affect the whole of the body. The virus, when it gets into the body, it goes and finds the particular body cells which it wants to affect, and then after getting attached to that, it multiplies and then it affects it. So that kind of a mechanism of a very nanoparticle drug delivery mechanism, which will go and find only the cancer affected body tissues and then deliver the drugs to that. So lots of studies and experimentation is going on right now all over the world to perfect and to make such a drug delivery mechanism so that we can use it very effectively. We'll just go through some 2, 3 more examples. One example is a hyena. Now you know that robotics, when you build robots, you want robots who can move, isn't it? Who are able to walk or run and so on. And we also have certain robots like a rover, which we put in a planet like Mars. We have put rovers in Mars, which will have to move through terrain which is very rough, not at all smooth terrain. So that it has scientists who study the movement of animals found that more than wheels, it is actually legs which can move over very rough terrain. And that too, instead of having a two-legged walk, if you make a four-legged robot like this, then a four-legged robot it will be more easy for such a robot to move across rough terrain and to even jump across certain obstacles if it comes before that. And at the same time, when it is a very smooth terrain, a wheel can come out of the hands and legs, and then the robot can actually move through wheels. So such four-legged robots have been made, and they have been found to be much more effective than the two-legged robots. And the inspiration here is the movement of the hyena, which is a four-legged animal which can run very fast at the rate of about 64 km per hour and so on, and jump over obstacles and so on. What are these? These are bats. Bats are certain organisms which are able to move in the night, isn't it? They are able to fly at night. How is it that the bats are able to fly at night? They are able to see sort of at night. The fact is that they use again sound. They they generate sound waves which are in the ultrasound waves. That is, the frequency of the sound waves are such that human beings are not able to hear them. They are beyond the range of sound waves which we are able to hear, but the bats can hear them. So the bats will make the sound waves. They will fall on any obstacles which are there on their path and get reflected, which again falls on the bat's ears, and the bats will be able to make out that something is there on my path and then move away. So this particular technique, which is called echolocation, has been made use of. We have made certain sensors which are able to give out this ultrasound, the sound in that particular range, and then when it gets reflected from any obstacle, these sensors will again catch it. And these type of sensors have been fitted into canes used by visually impaired people, challenged people, so that a vibration can be made onto the cane, and the people are able to move very smoothly across. So the bats are the inspiration for this particular cane development. Ducks have also inspired us. I'm sure you have seen the duck's legs, isn't it? Between the toes, there is a membrane that covers between across the toes. The webbed, it is called a web. So we say that the ducks have got webbed feet. The webbed feet actually helps them to swim, as well as when they drop into the water to reduce their speed and to make it possible for them to glide softly. And also, it's better to walk over muddy terrain, which ducks have to do. Now, inspired from that, we have made what are called flippers, which is actually divers use, isn't it? This kind of webbed feed that the divers use, they find that they are able to swim better without saving their energy. I mean, with using less power and less energy, they are able to swim faster, and even while carrying big equipments, I mean, weighty, heavy equipments, they will be able to swim. So the ducks have also inspired us for generating such products. So this is another example. You have all seen elephants, isn't it? And also the elephant's trunk. What is special about the elephant's trunk? The elephant's trunk is a very flexible body part, isn't it? The elephant is able to twist it, turn it, move it in all sorts of directions. Then it's also able to catch many things, pick up things from the ground, and then slowly, if it is some food, he's able to move it onto his mouth and so on. So when we build a robotic arm, the first we try to build it like a human arm. In that case, there were lots of joints. It was not flexible. But then some of scientists tried to develop a robotic arm which was inspired from the elephant's trunk, using a number of plastic discs along with compressed air, so that the arm was able to move like the elephant's trunk in a very flexible manner, and able to grip even very soft things like the apple. See, the robot is holding an apple without crushing it. At the same time, it will be able to hold very heavy things as well. And the grip that is used for holding the apple is the grip like our fingers, isn't it? The finger grip, along with the elephant's trunk's shape and the mechanism of movement, has made a very efficient kind of a robotic arm. And it's also the safety point of view also, this kind of a robotic arm is much better. Now there are many such applications. We'll just see a few more. Who is this? This is a mosquito. I'm sure all of us have been bitten by mosquitoes, isn't it? Sometime or the other. But the actual bite of a mosquito is not so much painful. It is not. It's only afterwards that we get the itch and so on. When scientists study this, they find that the proboscis of the mosquito, the part that actually bites you, it's actually a very complicated mechanism that is being used, consisting of a number of small needles are actually employed. So to build a surgical needle, which will help, the type of needle that is used to give injections, have been made which has been inspired by the mosquitoes that biting mechanism, in which it applies one straw-like mechanism along with two needles, so that the skin will be slowly kept away by two of the needles, and then that straw will go inside. So by this mechanism, it has been possible to build injection needles which cause much less pain. So and the inspiration behind this is the mosquito. These are maple seeds. The maple seeds, when they fall from the tree, they spin. They spin, and because of the spin, they are able to go far off places, which is what the plant wants. Now, this behavior of the maple seeds has been now applied for making what are called drones. The drones which fly, which turn and fly. That has also been applied. Another example are the cat's eyes. You have seen cats, cat's eyes, they sort of twinkle, and in the night, the cats are able to see in the night, isn't it? In the dark. Now, scientists studied how is it possible. They found that it's because the cat's eyes can reflect light back. It's because of that that they're able to see. And taking inspiration from this, now you must have seen some small protrusions which are put on the road. They are actually called as cat's eyes. When your car's headlights fall on those protrusions, they reflect back. They are coated with a material which will reflect back light, and then it falls on the driver's eyes, and the driver is able to see better in night. So it's a mechanism that helps in better night driving. There are many such examples. For example, there are lots of examples which has been inspired from nature in computing, in building computers, in the software and as well as hardware of computers. Like what is shown in that figure is the human nervous system, how our nervous system works. So, and also how the human brain works. How do we think? How do we learn? These are all aspects which have been directly tried to study and then to understand the principles and to apply to build computers. And now when we try to make computers which can learn natural languages, which can learn by themselves, or which can do artificial intelligence, I mean, all these areas, it is the human brain and how the human brain works that becomes the primary inspiration. So we have only seen a few numbers of examples. There are lots and lots of such products which have been made by looking into nature. And today it's a very vast and very fast developing area. And so then what is it that you can also do? This teacher is around you, isn't it? And there is a word for the people who actually look into the nature, get inspired, and then adapt and apply. It's called a bio-inspirationalist. So don't you also want to become bio-inspirationalist? So look around, see the nature. The idea is not to directly copy. That's not possible. Idea is to find out what's happening in the nature, the materials, the structure, the processes, the mechanism, something that may give you an idea, that may inspire you. And then find out the principle behind using our science, mathematics, and all that, and then find out what is the principle and see where it can be applied, how it can be applied, what sort of adaptation is required. Do that and then generate the new product so that it solves some of our problems or it becomes part of the solution for a problem so that our life becomes easy or the world benefits. So please do look around and become bio-inspirationalists. So I'll stop here and then see if there are any questions and answers. Thank you very much.
So thank you, Ms. Jaya Nair, for that wonderful presentation. So now it's our Q&A session. So you guys, if you guys have a question, you guys can type it in the chat and we'll try to answer as many as we can. So the first question is, how did the first humans come on Earth?
Yeah, the first humans did not come on Earth, they actually evolved. The evolution of life was a very long process. After the small life forms first formed, then more complex life forms formed, small insects. First, the life was formed inside the oceans, inside water. Small water animals, small water insects, fishes were formed. Then after the trees and other land plants formed, the little more complex animals like insects, like small foxes and other animals developed. And then slowly the mammals came. And in between there was the period when dinosaurs were there and then they became extinct. Then afterwards the small mammals evolved and then larger mammals like the larger animals came, the apes came. And from the great apes like gorilla, the chimpanzee and all came. And from there onwards, again, the evolution happened. And then many kinds of Homo species happened. Homo species like Homo erectus, the Homo and so on. And then finally it came to the modern humans, that is the Homo sapiens. So it was a long process of evolution. And many of the other earlier species actually got extinct. So today, the only kind of Homo species that is alive in the world is the Homo sapiens. So it's a very fascinating story. If you can just read through that, how from the tiny life forms, the evolution happened into different species, and then the Homo sapiens or the human beings evolved.
Okay, so our second question is, how is tape made?
Which
How is
tape?
tape?
I think that tape means that the Velcro tape. No. I think you mean the Velcro tape, maybe, because that was our first
Yeah, I
example.
think so.
Yeah, that is actually made of nylon. Nylon is one material in which that tape is made, and you can just see that Velcro. If you can just see that, then on top of that, the tiny loops are made by special materials and then pasted onto that. Then this whole nylon material is actually put onto the attached to the particular fabric or the shoe or whatever you want to press together. That's all.
Okay, so the next question, I don't quite understand, but maybe you do. It says, by studying ants, make the internet faster?
Studying ants, okay, you what you mean is that you want to get inspired by some of the ideas that the ants are actually applied. That's a very good idea, I think. Ants also have a very organized life, isn't it? They move in groups, they do work, they somehow find out how to do that work, they move in a line. I mean, many such mechanisms the ants are using. Now what you have to do is just find out what it is that you want to solve. Do you want to see how the things evolve in an internet? One thing is that internet is also not centrally controlled, isn't it? There is no single control who says how the messages have to be routed, where things must go, and so on. In internet also, you see that decisions are getting made on the way. That's very correct. So in that way, you can find some sort of a correlation. Now from that point onwards, you have to see what is the particular problem that you want to solve in internet. Then see whether the life of the ants, study the life of the ants, and whether an idea can contribute. I think it's a good idea that can be pursued.
Okay, so this one is referring to the first humans. It's, how did they learn to speak?
Oh, that's a very complicated question. I mean, here for questions like these, no, it's very difficult to correctly pinpoint and say this is how they learn to speak, because we are talking about very old times, very ancient times, in which there are no records of what happened that is available. There's no written history as such. So then, what do we have? What we have are only the materials that they have left behind, which we get through archaeological explorations and excavations. We get the fossils or the kind of materials like the tools or the whatever those human beings left behind, which, and from that we have to reconstruct. So then, what anthropologists, the people who study how the human culture evolved, they have tried to find out. They then try to find out what could have happened. I mean, we cannot say for sure this is what happened, but what could have happened. One possibility is that human beings again could have looked around and see how the some of the animals are making contact, how they are making sounds. So the human beings also must have tried to make sounds like that. They have tried to use sign language, and then they must have used some very rudimentary some sort of noises which will indicate certain things, and like that, and then slowly evolved into making small uh, words, and then evolved into language. Now you can see that the Homo sapiens, if you see over the last 300,000 years, they have not changed. The brain size or anything has not changed, but the intelligence has changed. The way we use our brains has definitely increased. That is because we work from we make one progress, one stride, or one path we make, and then from that we go to the next step. So next, it seems like success, isn't it? So that way, slowly the human beings have evolved to speak.
Okay, so this one is, what created or what caused the Big Bang?
what exactly caused the Big Bang? I do not think all the scientists have pinpointed on exactly the reason and so on. There are many theories which have been proposed about what must have happened, caused the Big Bang. There is also the theory that it was not the beginning. There must have been the previous universes which shrunk, and again this happened. Right? This is a cycle that goes on and on and on and so on. So it's a very fascinating area, and I think you can go and read through the many different theories that are there. There is no one particular reason that can be done and that has been done.
Okay, so the next question is referring to the first humans again. It's how did they interact?
Interact means, I mean,
I think it means like how did they socialize?
they socialize. Again, no, these are sort of questions in which we can even the scientists can only speculate. I mean, based on the whatever evidence that they have got, they try to speculate and move forward, isn't it? And anyway, so they again, human beings are a very social. Human being is a social animal. We have to be together. We try to be together, and the first human beings had so many things which they had to fight, even to get their food. I mean, they had to work together and then scavenge animals or collect from the fruits or other things from the trees and so on. So they were then later on they became hunter gatherers and so on. So slowly they learned and they grouped together and did the work. I mean, there are many theories. I think most of the questions are actually about the human evolution, which is not really our topic of interest for today. Yeah.
So the next question is, what were the first animals to be born?
Born in the sense that
I think they mean born in the sense that what were the first animals to
mammals.
come to life?
Yeah, that is what it's a long evolution. You can read about that. The first animals, you mean the first life forms, were the very small life forms like bacteria, one cell, and then for a long period the life forms that evolved were just cellular multiplication that was going on, and it was only very later that the other animals, which you call as animals, actually formed. So it is a long process of evolution, which I would say that you can just read on that. I mean, it's not a simple thing which can be answered just like that.
Okay, so the next question is, what happened to the nature around the dinosaurs when the asteroid hit the planet?
You know that the dinosaurs all got extinct at that time, isn't it? Some 65 million years ago. That because of the asteroid hit. That's a theory that is being that the scientists are proposing now. So there was, I think, the nature also got affected. I mean, all the life forms got extincted, except for some very small animals. All the other life got extinct, and then from these small mammals, which was left behind, again evolution happened, and the further life and the world as we know today existed. So nature also got affected, definitely, and it is even proposed that for many years then it was full of dust. I mean, sort of the world was there was no atmosphere as such. I mean, it was full of dust and so on. Anyway, I mean, you can there is one area which you can, I think, further refer and see.
Okay, so this question is, in the presentation, it was shared that theoretically the Big Bang happened around 13.7 billion years ago. Our Earth is much younger than that. How did people discover when the Big Bang might have happened?
Oh, that is, these questions are not simple questions. It's by means of long studies. I mean, there are from in the case of the Big Bangs, because of there are certain, you must have heard of the cosmic radiations which have been left behind by the Big Bang, and those which are scientists have been able to find traces of those radiations even afterwards. So that was one thing, and again, this is an area in which I also have only the whatever information that I have tried to study, and I also see that they have not found anything that is older than 13.7 billion years. So that is also one thing. These are not final conclusions, and these are all evolving fields in which astronomers and cosmologists are actually working on, and astrophysicists, and these are the dates which now they agree upon. Yeah.
Okay, so our next question is, how did the Earth and other planets how did the Earth and other planets form?
I think these kind of evolution questions are not simple. I mean, you have they can. It's not something that you can answer in 2 or 3 sentences. It was a long process over billions of years, isn't it? So Earth also, it did not form as such uh, after the Big Bang. But once the conditions were correct, in the sense that the small gases were formed first, you can read that how the deuterium and then hydrogen and so on were formed, and afterwards, the because of the particular conditions, it could be formed into the kind of planets and other heavenly bodies came into being. I mean, it is a very complex and very long story which cannot be just like that told. I think perhaps we can leave these evolution questions because people seem to be throbbing with those questions. What about our biomimetics?
Shall I just skip the evolution ones for now then?
Yeah, that's true,
Okay.
because these are not simple questions, and and perhaps I'm not the best person to answer also.
Okay, this one is, how can humans come up with ideas from abstract things like birds was the inspiration to make airplanes?
How did they do that? They just observe. No, when you want to fly, you see the who can fly. I mean, they saw that birds were flying, isn't it? Human beings saw that birds were able to fly and they were not able to fly. So that they tried to examine what could have been happening. They saw that the birds have wings and we don't have wings. So they tried to build something called a wing. You must have heard about stories like that of the Icarus. I mean, they put on some wings and then try to fly with, and they were able to fly. And there are many, many stories like that even. So that people might have attempted things like that. Then they tried to, they found that balloons were able to go up. So they tried to put lots of balloons together and then try to be taken up using the balloons. And then they saw the gliding motion of the uh, some of the birds and then try to build gliders. And like that they evolved. Whenever you want to do something, you see who can do that, where in nature that mechanism is already working, and then try to get the idea from that, inspiration from that, isn't it? That's what we do.
Okay, the next one is, what can we do to minimize pollution and help climate change?
What more we can do, you're asking?
Yeah.
And what's the question?
So it is, what can we do to minimize pollution and help climate change?
You mean how can we learn from the nature, isn't it? How can we learn from nature how to minimize pollution? Now we can see that it's in a way man's interaction with the nature which is actually causing pollution. That is lesson number one, isn't it? When we look around and see the other living beings, do we see them interacting with the nature in such a way as to cause pollution? Do we? Or are human beings the only species who do that? They interact in a way with our surroundings so that we affect our surroundings negatively. Then we build from that. I mean, how are we polluting the earth? So then reduce those interactions which are actually polluting. So this may be the way in which we can learn from nature. Then there are in nature we see that many of the mechanisms are self-preserving, like they somehow self-regenerate, isn't it? They sustain themselves. They do not affect negatively, and whereas they positively regenerate. So that is how we are now looking into those kind of activities which will not cause any danger to the nature, but at the same time our problem should get solved. So for example, energy source, instead of using coal or such energy sources, why not use solar energy, which is actually a self-sustaining and also not at all detrimental to the nature as such. And similarly, but at the same time we see that solar energy, the efficiency has to be increased. So we look at things like photosynthesis in nature, which is one way of using solar energy to build the energy source for all of us, isn't it? So like that, such points can be seen, I would say. And actually there are many work being done in this field. I mean, biomimetics is a field in which a large number of scientists are working currently. So if you just look at the internet and then try to find out what are the kind of applications for even this pollution or mitigating such problems, then you'll be able to find many, many solutions which people are currently working upon, getting inspired from nature itself. Yeah.
Okay, so there are no more questions, except for the evolution ones. So if you guys have any more questions, just type them in the chat.
Okay.
And I can see there are many discussions happening in the chat.
Yes, yes.
How do bats make sound waves?
How do bats make sound waves? That's a very technical question. We know that bats actually put out these sound waves. Now, how exactly they make, you will have to, I mean, we'll have to really see what is the particular biology in the bats that makes them possible for them to put out the waves. I think I'd also like to explore that. We'll do that.
I don't know
Many
this.
questions on the, yeah, I see that many questions on the kitty event, the extinction and all. I mean, that's somebody's replying also. That's very good. Nice. That's very interesting. You see how the world evolved, how the different life forms evolved, and how human beings evolved, and then how did we come to where we are today? All these are very interesting questions, but it's a long process. We are talking about billions and billions of years.
Okay, so I don't know if this is a question or not, but it's why did they trade instead of grinding it themselves? I think it's referring to something that happened earlier in the chat.
Mm-hmm.
We also have, let's see, what's under Antarctica?
Under? What is under? See, Earth is a sphere, isn't it? So the concept that something is under is because we usually show a globe with a north pole on the top and the south pole at the bottom, isn't it? Suppose we tilt it and hold it upwards. There is nothing like under or above because it's in the cosmos. The Earth is just like that, isn't it? So what is under? It's a sphere. So everything comes together. Suppose you tilt the globe and see. That's how it is.
I think what they meant was what is under the Antarctic ice.
Under the ice, the earth crust. I mean, everywhere it's the same. What exactly is the question? Antarctic, it's covered. The ice comes on top of the earth crust. No, that's how it is everywhere.
Yeah. Okay, wait, hold on. So it was a question, why did the olden people trade instead of grinding it themselves?
Trade? What's that?
Why did the olden people trade instead of grinding it themselves? I'm trying to make sense of the question myself.
Grinding what?
Yeah, that's what I asked them. What do you mean by grinding it? Grinding means working for it. Oh.
Working
okay,
for
so
what?
So why did they trade objects instead of working for them?
What objects?
I think referring to like before the invention of money.
Okay, barter system you're meaning. I hope that is what you mean. They trade things like if you want some apples, then if you have some oranges with you, you give the oranges and get the apples in return. Isn't it? The system is called barter system. That was before the invention of money. Now, why did people do that? Because they wanted other things. They had certain things. They wanted something that the other people had. So they could only give what they have and get the other things. Now, there were lots of problems with this. First of all, uh, how did you find what to exchange? I mean, how many kilograms of wheat will you give to get something else, some little bit butter? I mean, it was very difficult to really fix the exchange rates. That was one problem. And then the other person should also need what you have. If I have only some apples with me and the other person does not want apple, then I will not be able to trade, isn't it? So these were many problems, and that's why the somehow over years the human beings found out the idea or the concept of money, which was something which had a which could be exchanged for anything. And then for all the things we found out what is the exchange rate in terms of money, so that it became something that is perennial. I mean, always you can use it. It does not go waste. Like if I am not able to trade all my apples, then the apples may get wasted, isn't it? They'll become bad after some days, and I will lose all my money. And that didn't happen, and so on. So invention of money was a very big invention in the evolution of the human culture.
Okay, so this one is, when do you think the ozone layer will go away, or if it's in danger?
When we think exactly the date you're asking. Uh-huh. No, what is the question? When
So
we
when
think
you,
that,
so like about when do you think the ozone layer might disappear?
yeah, we are trying to not to make it disappear, isn't it? If the ozone layer disappears, it will be a great danger for all of us. You know that, isn't it? So now we see that the ozone layer is under problem, and then we are trying to mitigate. We are trying to find out solutions so that it does not get completely disappeared as such. So I hope that my answer is never. The ozone layer will never disappear. That should be the answer, isn't it? So we should all
Okay,
work for that. Yeah.
the next one is, why do beehives have hexagon patterns on them?
That's what the hexagonal pattern is, one pattern which is very strong. I mean, first of all, the hexagon cells, the adjacent cells tightly fit together. You can see that there is no gap without leaving any gap. So that is one shape which tightly fits together. There are other shapes also which fit together, but this is one shape that tightly fits. The amount of material used is less, and then it's also very strong. It does not get very easily crumbled. So because of these positive aspects that the hexagonal pattern has, the bees have used it. That's what they may not have calculated. I mean, we don't know. The things in nature, they have evolved in such a way that they are the best solutions for that particular problem. That is how things have evolved. So that is why we then scientists then found that that particular pattern, the hexagon pattern, could be directly applied to build materials which are lightweight at the same time very strong, which we wanted. That's why they were adopted, the honeycomb structure.
I think it's also because the hexagon allows them to use the least amount of their wax to hold the most
Yes.
amount of their honey as well.
True, correct. Because the in order to secrete the amount of wax which is required to make the beehive, the bees have to consume a lot of honey. So they wanted to somehow make the amount of material requirement to as low as possible. That is what they wanted.
Okay, so the next one is, can humans go extinct?
Can again, it's a speculative question. We cannot say, but looking at the evolutionary process, we should see that if you learn the lessons from what has been already happened, then what is it that we can expect? It's just by guess we can expect that the evolution will go on, isn't it? Because it has gone, it has always gone continuously on and on. So it is possible, I mean, at least theoretically, that the human beings can also evolve, another species can come, and then perhaps the species can become extinct. I mean, we don't know. And I don't know. We have to find out what the scientists are saying on this particular aspect. Again, we are talking about millions of years, big changes to take place.
Okay, so this one is, why do we have day and night?
That you must have studied, no? Why day and night happens. It's because of the rotation of the earth, isn't it? The earth is moving around the sun, at the same time earth is rotating in its own axis, and because of that, day and night happens. The part of earth that is actually facing the sun gets the sunlight and becomes day, and when the part gets away from the sunlight, night happens. So day and night happens at different times and different places across the world. isn't it?
Okay, so this one is, do you believe AI can overpower humanity?
Um, if you are asking personally, then okay, as a potential, this thing, you can say that artificial intelligence is something that who is making artificial intelligence? Who is the creator? Again, it's the humans, isn't it? It's human beings who are actually making the products which are and trying to instill some of the behaviors which we normally associate with intelligence. That is artificial intelligence. We associate learning with an intelligence, with an action of intelligence. We say that it's an application of intelligence by which we learn. So when we create a computer system or a computer software which can do a learning on its own, then we say that it has acquired intelligence. But then who is doing that? I mean, who is creating this activity? That is again by the human being who is actually controlling that. So the human being should also apply that the necessary controls in such a way that the artificial software which you have created, the learning software which you have created, is able to work within the limits and the controls that you have specified, so that it is to the advantages. Isn't it? In that way, I wouldn't say that human beings, the artificial intelligence can overpower human beings, because that is always under the control of the human being that it is working. And the kind of behavior that a very self-activating, acting on his own kind of a human behavior building, we are very, very far away from that. I mean, the sort of implementations that are being done are very, very, very much in the rudimentary sort of applications.
Okay, so this one is, if a universe is a group of galaxies, are there more universes?
That's one speculation or one question that scientists have been asking, and many explorations are also being done. But as of today, we do not have an answer to say that there is another universe. We do not have an answer. We are still seeking.
So this one is, what would happen to us if everyone stopped mining?
Mining what? Mining for minerals.
Yeah.
Yeah, first of all, everyone is not mining. No, are you meaning to say that
So
we
I
no
mean,
longer use any metals?
I think what they mean is, what would happen if we stopped extracting minerals from the earth?
Why do we stop? First of all, I don't know. Suppose we stop extracting minerals from the earth, then we won't be able to use those minerals, isn't it? So why do we do that? If you don't want minerals anymore, then perhaps we do that. In that case, it means that we have other materials which we can use in the place of minerals. So it's a truly a speculative question, I think.
Okay, so this one is, if we can't see ultraviolet light, how did we know those existed? If we can't see the ultraviolet light, how do we know those exist? Oh my God, it's just bad.
Okay, I meant human beings with their naked eyes cannot see the ultraviolet rays. Now, we do not, many things we cannot see. No? We cannot see viruses also, isn't it? Whereas we know that they exist and we study them. So we have the necessary mechanisms and the instruments which help us to study them. We have our scientists have the instruments which will help them to finally find out what are the different electromagnetic waves which are there on the around us, and among and where all the ultraviolet rays are also there. It's not that we are just looking with our eyes.
So this one is, do you believe that alternate or parallel universes exist?
Myself, I don't know. It's not a matter of belief, isn't it? We should have evidence. When we have evidence to know that there are alternate universes, then we accept that. That's all. So that is one area where scientists are trying to probe this question they are asking, and they are trying to find whether it is there, and they are trying to see whether there is any evidence for that. And the moment you get some evidence, then you start exploring further. It's not a matter of just like that believing.
So this one is, do you think space exploration is a good use of money?
Space exploration, definitely. What do you think space exploration is for? Uh, Even the space exploration is not only to know about the universe, that is one main aspect, and that is also very important. But by our space exploration, what we have done, we have been able to put satellites, artificial satellites orbiting around the earth, and using them so many different applications we have mounted. For example, communication, then there are the TV broadcasting, then weather forecasting, disaster management, isn't it? Finding out about the Earth's resources by means of remote sensing. We have been able to find out how the Earth's resources are going and where are the resources, where are the minerals. I mean, so many applications are there by which the life of the common people have benefited and keep on benefiting. Even this long distance internet and the mobile communications and all using satellites. So space exploration has many aspects to that. And it's definitely because it is something that benefits the life on Earth that we are doing that.
Okay, so this one is, what happened to the asteroid that wiped out the dinosaurs?
Dinosaurs, you're saying. Oh, as far as I know, then it is the theory that is being proposed that an asteroid hit the Earth, and that is why because of the great impact that happened, a lot of life got extinct, including that of the dinosaurs. What did the asteroid happen to that asteroid? I mean, that also it got broken, and then we can find out. I think it also got. It became a debris, and a part of it actually where it hit the earth, there's a theory that there is some part is actually there inside the earth. I mean, that is one thing we can find out. I think we can also search and find.
Okay, so this question is, how does the disappearance of Jupiter affect life on Earth, and more? I think what they mean is, if Jupiter were to suddenly disappear, how would it affect life here?
I don't know. That is a speculation for me also.
I think they mean like gravitational wise.
I don't know. We have to find how presently how is Jupiter benefiting us, or how is Jupiter affecting life on Earth presently. So is it actually contributing to the life on Earth? In what way it is contributing? And what way it is contributing to the Earth's movements and Earth's mechanisms and so on? And then then those things will be affected if the Jupiter is not there. I mean, these are very speculative questions, I think. We can find out what the scientists are thinking about all this.
Okay, so this one is, will all life on Earth be gone in some time?
No idea. I mean, your guess is as good as mine. We don't know. I mean, one asteroid hit once, isn't it? But then now we have mechanisms in place by which we are actually tracking how the heavenly bodies are moving, how the asteroids are moving, how the meteors are moving. And so we do have more control, more awareness about these things. But what will happen, who can say?
So this one is, some people think that the Apollo missions were faked. There's some evidence that supports against this. What is your opinion?
You are asking for my opinion. My opinion is that, I mean, that sort of faking is not possible. It's not so simple as to just like that fake it. I mean, there are many agencies which are involved. It's something that is involved all over the world, and there are many mechanisms by which you can find also if it is a fake. So I don't really think that it's a fake.
Okay, the next one is, when will the sun explode and when will the world end?
The sun's life has been predicted. Actually, it is there. I mean, I cannot just put a number onto that now, but there is the sun, is a star. A star's life, how the star's life goes on, we know that. So according to that, the sun's life is also has been predicted that after so many billion years, the sun also will become a dead star. Now, so anyway, that is a long way off, not in any of our lifetimes for sure.
So this one is, wasn't the asteroid smaller than the Earth? Wasn't the dinosaurs all around the world? So how did one asteroid extinct all of the dinosaurs?
It's not that the asteroids hit the dinosaurs. It's just that it was such a massive hit that all the life forms got extincted. isn't it? It's not about the relative sizes or whether it hit all the dinosaurs. That's not how it happened. Actually, that particular asteroid hit, you can actually refer to that and learn more about it. I mean, read the full story.
Yeah, so Phil, I think we can conclude. So we have like a few more minutes.
Okay, so that is a big thanks to Ms. Jaya Nair for talking to us today. That is basically the end of our class. I mean, I think we have time for like 2 more questions.
Yeah, sure. Please.
Okay, let's see. Actually, no answer. Let me just scroll up to find one. Let's start. I think we've already answered most of these.
Yeah, thank you, Ms. Jaya. It was a very inspiring talk.
Thank you.
So thanks everyone for joining. So we have one more session on this Thursday. So another scientist will be talking about Mars. She will be talking about the Mars mission. So if you guys are free, join. So it is on Thursday at 5 p.m. Same meeting ID.
Thank you very much. Thank you to all of you.
Okay, thanks. Bye.
All right, so with that, you guys are free to leave.
Thank you. Bye.
Wait, I have a quick little question about like the class.
Okay, go ahead.
Wasn't there like another class scheduled for tomorrow?
Yeah, so tomorrow we will have some science games. It is not a talk to a scientist session. So you can join tomorrow at the same time. So we'll have some science games and presentations.
And on Wednesday we also have one.
Yeah.
Yeah.
Okay.
Actually, I knew the answer to the Jupiter question.
Do you?
That's the answer.
Yeah, the asteroid crashes will be more common.
Bye.
How disappointing.
I was also in the meeting at the.
Oh,
Okay.
hello.
Thanks, everyone. Bye-bye.